So here's an example of using trigonometry to solve a right triangle. So when we are solving right triangles, as soon as you hear right triangle, you have to understand that SOHCAHTOA and the reciprocals apply to right triangles. It says a surveyor is standing 50 feet from the base of a large tree. The angle of elevation measured to the top of the tree is 71.5 degrees. How tall is the tree? One thing I notice with students is if I give them the diagram, not a problem. But sometimes students panic without a diagram. Let's draw it. Always a good first step. So here is our tree. A nice, beautiful conifer. And they tell us that this tree has some height. I don't know, because it's the vertical direction, I'll call it Y. And we are standing 50 feet away. I'm just following what the problem says. It says 50 feet. And we measure with our equipment that this angle is 71.5 degrees. And they ask us, what is the height of the tree? We have a nice base of this tree here. Yeah, look at that thickness. So we have the angle of elevation. We have the horizontal distance, but we don't have the vertical distance. We do have opposite and adjacent. We have this relationship. I'd much rather deal with tangent than cotangent. So I will say tangent of an angle is equal to opposite over adjacent. This implies that tangent of 71.5 degrees is equal to opposite is y over adjacent 50. If I want to isolate this y, I'm going to multiply both sides by 50. I'll get y is equal to 50 tangent 71.5 degrees. Now, I don't have a special 71.5 degree triangle. I better use my calculator for this. And when I do, I better put my calculator in degrees. If you're talking about a calculator that is a Texas Instrument CAS or a CX, you better go to Doc 72 or Menu 9. And when you crunch your numbers to the nearest hundredth, you get 149.43 feet. And that's this height here. Using more right triangle trig, remember, SOHCAHTOA applies here. You are 200 yards from a river. So here's you, this black dot, and you are 200 yards away from the river. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. Find theta, the angle between the path and the river's edge. So here is theta, and it says that you walk 400 yards along this path. So even if they didn't give you a diagram, you could draw this. Now, if you're 200 yards away, that implies it's the shortest distance. So that is a right triangle. You're going to find that perpendicular distance. You remember from geometry, that's the shortest distance between a point and some sort of line. All right, now look what we've got. If we put our cobalt black eyeballs looking through this angle, we have opposite and across from this 90-degree angle, the hypotenuse. So this in the black cut here is unknown. Because I'm dealing with, from that angle's perspective, opposite and hypotenuse, I'm going to say sine of this angle is equal to opposite over hypotenuse. So sine of the angle is equal to 1/2 when we simplify. And I do know something about unit circles. I remember I had a special triangle, 1/2 √3/2, and this angle was 30 degrees for the sine. So I can conclude by just knowing my special triangles that that angle should be 30 degrees. Note, I got lucky here that I had this special triangle to work with. Later, we're going to learn methods to find the angle that don't require luck. In our last example here, using right triangle trig, SOHCAHTOA, we're asked to find C, the length of the skateboard ramp, given that the angle of elevation here is 18.4 degrees, and opposite we've got 4 feet. Again, look, angle, opposite, hypotenuse, leads me to think that we're dealing with sine of an angle. Well, the angle here is 18.4 degrees. Make sure your calculator is in degrees, is equal to opposite over hypotenuse. Now we can go after C. Multiply both sides by C. So C times sine of 18.4 degrees equals 4. So C is equal to, now I'll divide both sides because we have C times sine 18.4 degrees. I'll divide both sides by 18.4 degrees, or sorry, the sine of 18.4 degrees. Now, if you have a smaller calculator, you're going to have to put that in with parentheses to let your calculator know this is my denominator. So if I have a small calculator, I overuse parentheses. I say 4 divided by this, and I put the numerator in parentheses and the denominator in parentheses. And when I do this, I get 12.67 feet. Notice I feel pretty good about that because the hypotenuse should be the biggest one. So if I'm given 4 here, I better have a number bigger than 4.